Yo, 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 this is Mr. O. Yo, 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 this is Mr. O. And today we're going to learn about the properties of logarithms. There are three properties of logarithm that you need to know. But before we go there, let's go with the basic one. The basic one, as a review, log of 8 with a base of 8, the answer is 1. Log of 1 to the base of 8, the answer is 0. The three main things are the product rule, quotient rule, and power rule. What is the meaning of this one here? If you have a log of RH are both logarithmic number with a base of 5, you can expand it and write it as log of R, the base of 5, plus log of H to the base of 5. Basically, the R and H here are being multiplied. If you can use the product rule by expanding them, you have to separate them by adding. So for example, if you have log of xy, the base of t, you can make it as log of x with a base of t plus log of y to the base of t. There you go. Now, quotient rule. That means when you're dividing. When you're dividing, you can write it as log of r, the base of 5, minus log of h to the base of 5. If you notice, the denominator here, which is h, had a minus or a negative in front of its log. Okay, one more. If I have log of, let's say, c 2/3, this means that log of 2 to the base of c minus log of 3 to the base of c. If you notice, with all of them, the base of 5 remain to all of the logarithm. Next, the power rule. The power rule, from the word power, is exponent there of the 4. The meaning of this one here, the 4 there will just go down. It will become log of r to the base 5, but there should be a 4 in front of the log. So if I have log of, let's say, x squared to the base of y, these two here can go in front. So applying the power rule, it will be now 2 log of x to the base of y. One important thing that you have to know is that log of square root of x to the base a. Remember, guys, that square root of x, there's invisible 1 and a root of index of 2 there. That means it's x to the 1/2. In other words, this log of square root of x to the base a is same thing as log of x to the 1/2 with the base of a. And that 1/2 can slide in front and becomes now 1/2 log of x to the base a. Or sometimes they write it log of x to the base a all over 2. Okay, they meant the same thing. Okay, let's go now to our example. Expand using log properties. So I have your log of xy squared z with a base of 3. So they are all being multiplied. So I have to expand them in three different log of x with a base 3 plus log of y squared to the base of 3 plus log of z to the base of 3. Are we done here? Yes, are we done here using the product rule? But we're not yet completely done, because here I have a squared. This 2 here of the y can slide in front of it. So the answer is log of x to the base 3 plus 2 log of y to the base 3 plus log of z to the base 3. And that's the complete expansion of this problem. Next, log of 3w over a. Again, remember the quotient rule. Whoever is in the bottom has to have a negative log. So here, let's split them first as log of 3w to the base 2 minus log of a to the base of 2. Now, if you pay attention here, you're multiplying 3 and w, so I can expand them. by log of 3 to the base a plus, because we're multiplying, log of w to the base a minus log of a to the base 2. And that's the answer. Kaboom. Next, again, we know that square root of e is same thing as e to the 1 half. And we know everything in the bottom has to be negative, and everything that you're being multiplied are going to be expanded by a positive. So how does it work? Here's the rule. Just remember, everything in the bottom has to be negative. Remember that. So let's go ahead now. So log of e to the 1 half over 3s squared base of t, expanding them. So log of e to the 1 half base of t minus log of 3 to the base of t minus log of s squared to the base of t. They're all minus here because they're all coming from the denominator end. The 2 here will slide down or slide in front, and the 1 half here will slide in front there. So the final answer will have a 1 half log of e to the base t minus log of 3 to the base t minus 2 log of s to the base t. And that's the complete expansion. Kaboom. Next, same thing with this. The index here is 3. So therefore, log of 4d together of 1/3. Because the invisible exponent here is 1, that's why it's 1/3. Minus log of 8p. Okay? Now remember, guys, that this 1/3 goes with 4 and d at the same time. So I can rewrite it as log of 4, and there will be a 1/3 here, plus log of d with a 1/3 again, minus, now remember the 8p are both the denominator, so they have to have negative there, log of 8 minus log of p. Now, this 1/3 here will slide in front, and same thing with this. That give us a 1/3 log of 4 plus 1/3 again with log of d minus log of 8 minus log of p. And that's the complete expansion form. Kaboom. Let's do now the opposite. The opposite of expanding is condensing. When you condense, that means there should be only one single logarithm here. So it's the opposite of what we just did for the first part of this video. So this is the expansion form. I'm going to put them in a single log. So I'm going to put log, and I'm going to write here already the base so I won't forget. Since these are positive, I know that they will be on the numerator. Since this is plus, I know I'm going to multiply the r and the w, so I'm going to have here rw. Since there's a 2 here, not negative 2, the negative is telling us that it's going down. The 2 here will go up as an exponent of f, so f squared. If you notice, I put the f squared under the rw, not the entire log with a base 3. Some kids, they will do it this way, log of rw with a base 3 divided by f2. This is wrong, okay? You have the f squared under the rw, and that's the answer. Kaboom. Next, we know that there's a 1 half here. It could go up on the u. We have a 1 half here. It could go up to the q. So it will be log of square root of u times square root of q with a base of r, right? Minus, if it's minus, they have to go on the bottom. This will be a 5, and this will be a k here. Okay, so now the complete answer will be log of square root of uq over 5k to the base of r. And that's the answer. Kaboom. And that's how you apply the properties of logarithm. And as always, kaboom.